Okay, so the theory of resonance. This is usually one of those concepts that students find real challenging. And I would say that the best way to explain it is using the benzene example. Now, the benzene molecule is oftentimes represented using this structure right here, which is also known as the Kekulé structure, named after the chemist, German chemist, who came up with this idea for the structure of benzene. And basically, according to the resonance theory, in some cases, a Lewis structure is not sufficient enough to accurately represent what the true structure of the molecule is. And benzene is a very good example of this because, according to the Kekulé structure, you would expect that because this is a double bond and this is a single bond, you'd expect that the double bond would be shorter in length and the single bond would be longer. That's what you'd expect based on the Kekulé structure. However, it was experimentally determined that all the bond lengths, all the carbon to carbon bond lengths are the same. So, according to the resonance theory, when a situation like this occurs, one can draw another structure where the only difference between it and the previous structure are the positions of the pi electrons or the double bonds. So, according to the resonance theory, this structure and this structure are canonical structures. Canonical structures. All right. And the real structure is a hybrid between these canonical structures. All right. So basically, the real structure has some characteristics in common with one and other characteristics in common with the other. And in some textbooks, they represent this hybrid structure with a regular hexagon ring and a circle in the middle of it. Now, in my classes, I sometimes use the example of the biological relationship between a horse, donkey, and a mule. All right. As we all know, a horse and a donkey, those are two different animals, and the mule is a biological hybrid of the horse and donkey. So what that means is that the mule has some characteristics in common with a horse and other characteristics in common with a donkey, but of course a mule is not exactly 100% horse, 100% donkey in terms of characteristics. So that's basically the analogy I try to use in order to help my students gain an appreciation for the whole idea behind the resonance theory. Okay, that's it.